Thank you so much. At this time, we'll open it up for questions from our judges. Who wants to start? Here.
First, I want to say thank you, to all the other teams, and there's no conflict of interest, there's no relation between Chris and I, even though we have the same last name. One of the things that wasn't clear to me from either the written paper or the current presentation is, what are Cuba's renewable energy goals? You stated in there that they had a 20%, 20-some percent by 2030. At an estimated cost of $3.5 billion is what I recall from the written presentation. But solar was only like 1/3 of the goal, if you will. What else are they relying on, and what are the costs associated with it? What are the alternatives, basically, to renewable energy?
So they have a couple things. They're doing a lot of wind right now, and they also have solar is a big thing. But combining the two was what we really wanted to emphasize. They also have sugarcane is a big product out of Cuba. So they have something called bugasi. I'm sure I'm probably butchering that. Can also be used as a biofuel. So sugarcane crop it's fluctuating the past couple of years. It used to be really big. It hasn't been quite as big the last couple of years. They can use something called that combined with a cogeneration plant. So they have they produce the sugarcane, the bugasi that's left over. They can be used as a biofuel to they burn that and they make steam and produce power out of that, which whatever's leftover energy from the sugarcane plant can be sent back out to the grid.
Thank you. This is a 12 megawatts plant what you're proposing at this point, and it is in an existing area that has infrastructure associated with it, et cetera. I am assuming that there's going to be a very limited number of opportunities for something like this, where you can co-locate an existing wind farm with transmission associated with it, et cetera, close to a population center. Based on that, I'm assuming that the rest of your proposal will be to look for these particular opportunities first, and then expand to other areas where the potential may be higher, but will require significant transmission in order to deliver the resource, et cetera.
Yeah, so definitely that's kind of our main point of our proposal is, since there are a few wind turbines already in place, there is a lot of available land around them. As Justin said earlier, Cuba has a limited amount of space, so our proposal is more of maximizing the space that's there. If there is space available to install solar panels right by a wind turbine, for example, it maximizes the land area usage, and it produces the most amount of power per acre, or however much space you have available to you. And moving forward, you can easily look for other locations to maybe implement both technologies from scratch. But at least for the case of this proposal specifically, we are looking for wind turbines that already exist, and just further enhancing them with additional technology to sort of pick up each other's slack in a sense. When one isn't producing as much energy, the other one can probably produce some of that electricity that's being lost.
Another one of your points that you made was that Cuba basically has somewhere around 17% transmission and distribution losses. If you don't want to penalize every new source of generation, regardless of the source, whether it be renewable or new gas or whatever, with a 17% penalty, have you considered what could be done to improve the T&D system in Cuba? And I'm assuming that they're not including losses in the calculation, but if they do, that needs to be addressed also. I'm sorry, theft or non-payment of.
Yeah, that's definitely. So one of the main causes of their transmission losses, it's improperly mounted. I believe it's conductor mounts. So maybe I guess renovating or upgrading those specific mounts that were improperly mounted will probably decrease the transmission loss that they currently experience.
Yeah, the insulation is one of the main efficiencies. That and the old technologies, the other thing.
Yeah, again, congratulations. Did you look at the solar farm that Florida Power and Light has here in Florida for any of your data, or
We compared it mostly to the ones in like Southern California. There's a 579 megawatt in, I think it's Rosada, California. That was our main comparison for it. Was the kilowatt hours per square meter was almost 5, so it was close. So we just had we got most of our numbers for taking a ratio from how much output they get at 4.9 kilowatt hours per square meter, and converting that into like the 5.6 kilowatt hours per square meter that the Guevara area has.
Okay, and another question is, here, obviously, where you have a solar farm, you're tied to a grid that has a production capacity that can produce whatever electricity you need at night, and also you peak during the day. In Cuba, when you put a solar facility like this, how are you going to do the night, how are you going to handle the night loads?
That's part of the reason why we think it's a great idea to have it tied in directly with the wind. I mean, usually when it's sunny, it's not always the windiest. So when it's windy, like during a storm, you'd be getting a lot of power from the wind, and you wouldn't be getting much from the sun. But on a sunny day, I mean, there's 330 sunny days on average in Cuba. It's a lot of sun. So during the peak hours in the day, they should be covered. But like you said, at night, they could have capacitor banks or something to help cover that. But usually, it would probably just be the wind, and then back to the old oil power generation at night.
Thank you.
Congratulations for your work. And I would like to ask you one question. Why do you selected Hibara? Because you have wind devices over there?
Yeah, so we selected Jibaro just because, one, because there is wind, and just when we were trying to locate the wind turbines already in Cuba, a lot of our sources were sort of misdirecting us to where exactly these wind turbines were collected. So we were able to locate the Jibaro one, so we kind of just stuck with it just because it was probably the most reliable information that we could find. But this could be easily be implemented in different sections of Cuba where other wind turbines exist. We're not limiting it not only for this specific location, but just for the sole purpose of our proposal, we just focus on this one location.
I am not an electrical engineer, but I would like to ask you how efficient is to storage the energy that is obtained from all three sources? I mean, could you storage, or you have to use it continuously, day and night, or not?
So you can have like battery packs and such on, and such as for the storage of the energy. For example, like Tesla, for example, I believe they produce sort of these battery, like industrial sized batteries that, could charge up and sort of save the energy and then be used, during off hours at night or something like that. So you could use batteries to sort of gather and collect that energy and use it for later use.
Generally, it's not cost efficient to do that. You just, whenever the energy is available, you use that to supplement what you have, and the main power plants, the oil would just kind of come offline or come to a low while the solar kicks in, and then, vice versa at night, the regular old power plants, the oil would come back online, and the solar just wouldn't produce much of anything. Hopefully, the wind would supplement as well.
Great job. I hope that you make it back home safe and that the flood has not affected your families. Questions have been asked by previous judges that I had here in front of me. And I had already cleared the fact that Villar was not related to Dr. Villar, that he's Dominican Colombian descendant. And I love to see the diversity shown in our industry and how it really applies to any infrastructure around the world, and this one specifically in Cuba. So I wish you all lots of luck, to all the teams, and congratulations.
Thank you, judges. One point that I do want to make specifically, and I think some of the judges have hinted at this, I think knowing that as a Cuban descendant, and I was here at this stage several years ago, working on these projects, there's very little information outside of Cuba that we have access to. I think Elizabeth mentioned on this because she worked specifically with the University of Havana, but there isn't much access to real life information for some of the engineering mechanisms that we're trying to explain. And in addition to that, we have students that are non-Cuban descent, have never stepped in Cuba in their life, not only presenting to experts in the engineering fields, but experts in Cuba. So I do want to thank you guys for that, because putting yourselves out in this position to be judged on the culture that is not part of the specifications here is very important, and I do thank all of you for that. At this time, I do want to open up the floor for questions from the audience to this last team before we break for lunch. Any questions? Okay, so we will go ahead and take a 1-hour break. We will reunite here at 1 o'clock. And at that time, we will have our award ceremony where we will award first, second, and third place to the teams presented here just now. So thank you again. One big round of applause for this last team.
I want to thank everybody for here in the Cuban Museum. And using as the Cuban Museum is the Cuban-American Museum of the Cuban Diaspora. But the exhibits are open. If you want to go, there is three galleries on the first floor, and then the one over here, and they have an exposition right now ongoing, so you're welcome to visit those.